Morning, students. Today, we will perform our next topic, that is SDLC models in detail. Okay. In a previous lecture, we have studied the different model, that is waterfall model, and that concept is in a brief. Okay, what is waterfall model? What is prototype model? What is your evolutionary model? What is your spiral model? These are the models that are in your syllabus. Okay, and these models we will study now in detail. Why these models are used, for what project they are used, okay, their advantages, their disadvantages, and why your evaluationary model came. Then after that, why spiral model will become. Okay, all that concept we will study in our today lecture. First of all, the SDLC model. SDLC stand for your software development life cycle model. Okay, and in your SDLC there are total 6 phases. First phase is your planning, then requirement gathering or analysis, then design, then coding, then testing, and last is your maintenance. And all these phases of your software development life cycles are also followed by all these models. Okay, first model is your waterfall model. Okay, why the name is given to it, waterfall, that we will study. Okay, then next is your prototype model. Okay, prototype is also known as your toy model, throwaway model, or dummy model. Okay, why the name is given to it as a prototype, that we will study. Then third model is your evolutionary model. It is also called as an incremental model. Incremental model, and last is your spiral model. Okay, and all these models follow your SDLC, that is software development life cycle. Their phases are used in these models. Okay, first model that we will study is waterfall model. Okay, your waterfall model is the oldest and the most well SDLC model. Follows a sequential step-by-step process. Okay, in your waterfall model, this is the oldest model, and it is also called as a basic model. Okay, and it follows your sequential step by step are there, means first step will be completed, then we will go to your second step, second complete, then go to the third step. Okay, sequential concept is there. Process from requirement analysis to your maintenance phase. Okay, the first phase is from your requirement analysis till your maintenance phase. It will be followed step by step. Okay, system that have well defined and understood requirements are a good fit for a waterfall model. Means those project or the system that have a well defined and a complete requirement information. Okay, we have a complete requirement information from user and it is well defined. For that, we will go for a waterfall model, and this waterfall model is used for your small projects. All the phases in the waterfall model must be followed anyway for a successful projects. Okay, and all these phases, and the phases are your feasibility study is there, requirement analysis and gathering is there, designing is there, okay, coding is there, testing is there, and maintenance. All the phases, these all the phases in the waterfall model must be performed anyway for successful project. Okay, to make a successful project, we have to follow all these phases in a sequential manner. Okay, and the last point in your waterfall model, any different ordering of phases will result in less successful. If we not follows these phases in a sequential manner, there will be a fault project. Okay, your project will not work properly. Okay, now we will study our waterfall model. I will draw this diagram on board step by step. Okay, and your waterfall model look like this. Okay, I will draw this model on board and explain each and every step. We are studying the concept that is STLC model, and there are four models are in syllabus. That is waterfall model. Okay. There are two waterfall models. First is your classical waterfall model. You draw the diagram how it's look like. Okay. Classical waterfall model is there. The drawbacks that come in your classical waterfall model will be fulfilled by your iterative waterfall model. Okay. This is your iterative waterfall model. In this model, we will add a feedback concept. In your iterative model, we will add a feedback concept, but in your classical waterfall model, there is no feedback. Is there? Okay. Feedback means we have to complete a complete project, hand over to customer, then we will maintain it. Okay. Then we will maintain it. But in your iterative concept, there is a feedback. If a developer wants to change anything, any team member wants to change any concept in a design or in a requirement analysis or in a coding, they can backtrack that. Okay. Then there is a second model that is a prototype model. Okay. Prototype model is also called as your toy model. Toy model or your dummy model. Okay. It's also called your toy model or throwaway model, use and throw. Okay. That also the problem that came in your waterfall model or in these models are used for small projects. Okay, these two models, but in a prototype we will fulfill the drawbacks that came in your waterfall model. Then there is a third model that is your evolutionary model. Okay, evolutionary, or we can say that it is an incremental model. Incremental model. Okay. And last is your spiral model. This model is also called as meta model. Okay, we will draw the diagram of all models. First of all, we will go for a classical waterfall model. How it's look like, what are the phases in your SDLC model. First is your classical waterfall model. In this first phase is your feasibility study. Feasibility study. Then, when this feasibility study will complete, it will go to next phase. Sequential process is there. Okay. Second phase is your requirement gathering and analysis. Requirement gathering and analysis. Then go for a next phase. If it is completed, then next phase is your design phase. Okay. After completing this, go for next phase. Then it is coding phase. That is implementation, development. If it is completed, then go for next phase, that is testing phase. Okay. If it is completed, deploy the product. Okay. Means hand over your product or a software to the customer after complete testing is there. And after completing the testing, you have to deploy your product to the customer. Okay. Here it is. Deploy means hand over the product to the customer so he or she can use the product and give you the feedback. Okay, that product is okay according to his or her requirement or not. And last phase is your maintenance. Then you will go for a maintenance. Okay, these all steps for a team developers, a software developers. First is feasibility study. Second is requirement gathering and analysis. Third is your design. Fourth is your coding. Then testing. Then maintenance. Okay, this is your classical waterfall. Okay, and why the name is given waterfall? Because it is look like a waterfall. Means first mountain, water came, then go to second mountain, then third mountain, then fourth mountain. Like the same way your waterfall flows. Okay, the same way in your project will be flow from your first phase to the last. Okay, first phase is your feasibility study. What does this mean? Feasibility study means your project means we have to study as a team manager or a software manager. I have to study the project that I can develop that project economically feasible. This the product I am developing. It is economically feasible or not. Economically, financial, it can be developed or not. It is in a budget or not. Okay, next is your technical feasible. Technically feasible or not. Okay. Okay. First phase tells that as a team manager, my product is economically or financially feasible or not. Means first of all, to build that product, I should keep in mind that project should be in a budget. Okay, that is financially feasible or not. Okay. Then there is a technical feasible or not. Technology should be used. Latest technology can be used or not. Okay, that is your technical feasible. Okay. Next phase, after completing this study, that is feasible study, then we will go for a next phase, that is requirement gathering. Then, as a team member or as a project manager, I will gather the requirement from the customer, from stakeholder, from expert person who already developed the same project or any of the project. Okay, experts will be there. From these person, I will gather the requirement. Okay, and then analyze it. Okay, there will be another team member that will analyze that requirement. Okay, this is all done by a teamwork. If I am doing a feasibility study, there is another team member of my organization that will gather the requirement and another team member that will analyze that requirement. Okay. This is all done by a team member. Then after completing these requirement and analysis, okay, Then it will be hand over to next phase, that is designing phase. Okay. And in your designing phase, there is another team member who will create a architecture of that product or of that software design. Okay. And design is further divided into two parts. There is an initial design and second is your detailed design. Detailed design, that we will study what the difference is in our next slides. Okay, but there are two types of design, that is initial design and detailed design. Okay, but design is your complete architecture, that is your model, prototype like structure. Okay, you have to create a design of that software. Okay, and this design is completely dependent on requirement gathering and analysis. The point I have missed here. In your requirement gathering and after that analyzing is there, we have to write a documentation. Documentation should be there. Documentation. Okay, and this documentation in software language, it is called as SRS. Okay, keep in mind, because in our next practical we will draw a SRS of our project. Okay, and this SRS full form is software requirement specification. Software requirement specification, and this come under your second phase, that is your requirement analysis, gathering and analysis. Okay, your documentation should be there. After collecting the requirement, after analyzing it, we have to, as a team member or as a developer, I have to create a proper formal documentation. Document should be there, and that document is called SRS, software requirement specification. Okay. Then when we go to a design phase, okay, the team member who will create a design, he will follow that design according to the SRS. What is written in the SRS, design should be created according to these points, the documentation, that points written in that document. And that document is your software requirement specification. Okay, design should be according to this documentation. Okay, then I have told that design is of further categorized into two types. Initial design is there, detailed design is there. Okay. Next, after completing a design, we will follow a next phase, that is coding. And coding should be done according to the design. Okay. Design is done according to SRS and coding is done according to your design. What is design is, what type of design have made. Okay. Then go for implementation. Okay. In your coding, you will write the code in different modules. First of all, you will write a module 1, then module 2, then module 3. Okay. In the distributed manner. Okay. I will distribute this coding to different programmers. Module 1 will be created by a programmer 1. Module 2 will be created by a programmer 2. Module 3 will be created by a programmer 3rd. Okay. And in your coding, there is also a concept that is unit testing. Okay, unit testing is there. Unit testing is there while coding. Unit testing means if there is a module 1, module 2, we have to test this module unit wise. Means first of all, I will test module 1, then go for module 2. Okay. Means we have to test each and every line and we have to perform a single individual testing of a single module. Okay, that is why in your coding there is also a concept of unit testing. While coding, we have to test these code also. Okay. Next, in testing phase, there is after coding, after unit testing, there is a integration testing. I will write this side. In integration testing, there is also an integration testing as well as your system testing. What does this mean? Integration means in previous unit testing we will test single module at a time. Okay, but in your integration testing we will combine this module. Okay, we will combine this module, then means we will integrate these modules, then we will perform a testing on them. Means their interface, if they have a functionality between these two modules, they are dependent on each other. We will test both the modules integrated. Okay, that is your integration testing. If okay, this is your integration. If your system has total number of 4 modules, M1, M2, M3, M4, then we will complete test this module with a combination. Okay, or it can be related to each other. M1 dependent on M3, M3 dependent on M2, M2 dependent on M4. These are the modules that are functionally dependent on each other. For that, we also go for a system test. Okay, that's come under your testing. Then, after completing all these unit testing, integration testing, system testing, then we will deploy our product. Okay, deploy means we will hand over that software to the customer, to the users, so he or she can use it. Then, in maintenance phase, last phase is your maintenance. If there is any problem, if there is any concept that is not fulfilled according to customer need, then we have to maintain it or update that product. Means as a software engineer or a developer, I have or my team member have to perform this maintenance. Okay, this is your complete waterfall model works, and more effort will be in your maintenance. More effort. Okay, these are the phases and they're working, how they will work, what they mean, what the feasibility study means. Physical means it is feasible to make or not, economically, technically, or financially. Okay. Then requirement gathering. Second is requirement gather. We have to collect the requirement from the customer, from the experts, from your stakeholders, then analyze that requirement. Okay. Then write that proper analysis in a documentation. Then go for a design, then go for a coding, then go for a testing, and last is your main. Okay. This is the working how your SDLC works. Okay. Now I will tell you the advantages and disadvantages of your classical waterfall model. First, advantages is advantage of your waterfall model is it is basic model. Okay, it is a basic model. Simple projects, or you can see that small projects can develop using waterfall model. Okay. Next, disadvantage are. Okay, the first point we have studied in slide. This is the oldest model. Okay, this is the oldest waterfall model. It is classical waterfall. Then disadvantage are No feedback. No feedback concept is, what does this mean? Is if we are done feasibility study, then move for requirement, then move for design, then coding, then testing. Means if there is any problem in design phase, if coding team developer, if he face any type of problem in his coding according to design, he will not backtrack it. He will not help to the designing member. Okay, who will design the product. He will not go back to back. Okay. All that concept is done after deploying the product. After handing the product, then they will go for a maintenance if there is any problem in these. Okay, we will not backtrack. Means there is no feedback concept. Means if they have a problem, they give feedback to design. Okay, if testing will have a problem in coding, we can feedback to coding part. Okay, there is no option in your class. Okay, but in your next model, that is iterative waterfall model, these problem feedback disadvantage is removed in your iterative. Okay, now these are the basic problems that come under your classical waterfall model. Now I will go for a iterative waterfall model. I will draw the model. There is a small change in it that changes your only iteration is added. The name given is iterative waterfall model. Okay. The steps, the phases are the same. Feasibility study is there, requirement gathering and analysis is there, design phase is there, coding is there, testing is there, maintenance is there. But what the new concept is added, that is feedback module is added. There is a feedback between these modules. Okay. If there is problem while maintenance, according to testing, they can give his or her feedback. His team members who are developing the product or maintaining the product or testing the product, they can feedback, go back home. Okay. They can tell the testing team that they haven't tested properly. That is why there is a problem in it. Okay. If the testing team face any problem according to coding, they will backtrack, give a feedback to a coding team. Okay, give a feedback to a coding team that they haven't used a proper programming concept. Okay, that is why there is a problem in testing. The modules are not working properly. If there is a problem in coding, then it will backtrack to a design phase. Okay, we will, if they are implementing any code, that problem is arising according to design that the design team have made, then they will backtrack and tell the problem. If there is any problem in requirement analysis, then there is a feedback. If testing team face a problem according to the gathering and analysis, they will again backtrack directly to the requirement analysis. But there is no iterative or feedback in a business. There is no iteration. No feedback can be given to them. Okay. Because in your feasibility, that as a team manager, I have to check. Okay. But in a requirement gathering and analysis, we have created a documentation. We have created a documentation. Means commitment should be made with a developer, means as a manager and a customer. Okay, here I am the developer and I have made a commitment with a customer. Okay, the agreement is signed between a manager and a customer or a team member or a developer or a customer. Okay, these agreements are signed. But up to till we can feedback. After making a commitment, we will not change anything. Okay, but these all are iterative process is all for your team members who are developing the code. Okay. Up to this, we only interact with the customer. Up to this phase, we only interact with the customer. After taking a requirement, after completing a documentation, then we will go for a design. In this phase, there is no interaction with customer. In this phase, there is no interaction with the customer. Only up to this phase, there is an interaction. And in this phase, if we have made any commitment, then we will not change any process. Okay, then process will be changed when there is a maintenance phase. If the customer wants new technology, new product, then according to his requirement, we will again develop that product. Okay, that is your iterative order. Okay. Now we will study all these phases in a detail. What does feasibility study means? Okay. Next, what is your requirement analysis and gathering phase means? Okay, this is your waterfall model. Feasibility study is there. First phase. Second is requirement analysis. First of all, requirement gather should be there. Gathering collection should be there. Then that analysis is there. Second phase is there. Then designing is there. After requirement analysis, we have to create a design. After designing, we have to create a code, and it is also called as a unit testing. Okay. Then testing is there. In testing, we will perform integration testing as well as your system testing. Then last is your maintenance. Okay. First phase is your feasibility study. What does this mean? It determines whether a proposed system can meet the user requirement effectively. Okay, this phase determines that whether the user requirements can be fulfilled or not. It can be economically feasible, it is technically feasible, or financially feasible or not. Okay. Then the feasibility study is basically the test of proposed system in the light of its workability, gathering user requirement, effective use of resources, and the cost effectiveness. Okay, all the points come under your feasibility study, that the product that we are making, that should be feasible, working should be feasible. Okay, it should be work according to the customer need. For that, we have to collect the proper requirements from the customer. Gathering should be proper. Okay, resources are used. If we are using maximum resources, the budget will be go out of limit. Okay, if we are making a product and the budget is going out of limit, means we are in crisis. As a team member or as a team developer, we have to pay extra cost, but customer will not pay that. Okay, so last point is the cost effectiveness is there. Okay, feasibility is there. Okay. Next point is feasibility is categorized as a technically feasible, operational feasible, economically feasible, schedules, and social feasibility should be there. Okay, it should work properly. That is operational. It should work according to technology. Latest technology should be used. Economically should be there. Feasibility should be there. In cost. Okay, and social feasibility should be there. Okay, what the customer wants. Last point is the main goal of feasibility study is not to solve the problem, but to achieve the possibilities. Okay, this is the main. That main goal of feasibility study is not to solve the problem. We haven't solved the problem, but we have to make an effective product. Okay, but to achieve the possibility. If it is a proper possibilities are there, we are making an effective software. Then there are further decisions are there in first feasibility study. First one is your product should be economical feasible. Okay, economic means cost, in cost. Okay, in budget should be there. Your product we are developing should be in a budget. Operational feasible should be there. Okay, it should be worked properly according to customer needs. It is easy to use because customer do not have any knowledge of a programming language, any testing language, or any maintenance. Okay, so it should work properly, easy to use. Organizational feasible. Okay, what does this mean? Whether the proposed system is reliable to the organization's strategies, or not. Okay. If any organization want to make any type of software and their team members are working on that software as a customer, the team members are working as a customer. Okay, they can easily use that product like Zoom. Okay, Zoom is also your software. It is developed by your Zoom organization. Okay, and we are using this application. Okay, and it is easy to use. Means organization feasibility should be there. If we are using in the college, it is easy to use. We can use it properly. Okay, without any problem, without any technical issues. Okay, then there is a technical feasibility is there. Whether the problem be solved using existing technologies or resource available, latest technology should be used. Okay, should be work. This Zoom should be work on Windows 7, Windows Vista, Windows 10, XP, and your Linux product also. It is technical. Platform dependent should be there. Social feasibility there, whether the problem be solved without causing any social issue. Okay, if there is a problem in any product, it should be easily solved. Okay, that is social feasibility. These are the decisions should be keep in mind while making a product, while going for a feasibility study. Okay, economical feasibility is there, operational feasibility should be there, organization feasibility should be there, technical feasibility should be there, and last is social. If there is any issue that can be easily resolved. Okay. Next phase is your requirement analysis. Second phase. In this phase, first of all, we will collect as a developer, as a team manager, we will collect the requirements, gather the requirements. Okay, from different resources. Here, the defined software condition completely and should be documented with the customer before passing to next phase. Okay, if we have collected the requirements from the customer, then analyze that requirement, then we have to create a proper documentation. Should be okay, and that documentation is called SRS, Software Requirement Specification. Okay, then second point is requirement have to be collected by analyzing the need of the end user and checking all the possibility to implement them. Okay, there should be a proper checking. Okay, that is analyzing should be proper according to the requirement that is gathered from the end users. Okay, then last point is the aim is to generate a requirement specification document. Okay, requirement specification document, and that is your SRS, software requirement specification. The name is software requirement specification, and this is the documentation. And this documentation is used as an input for your next phase, and next phase is your design phase. If there is a proper documentation, then we will go for a next phase, that is a design phase. Okay, and there is a further your requirements are there. They are categorized into two parts: functional requirements and non-functional requirements are there. Okay, in your second phase, in requirements, that is requirement gathering and analysis, there are two different categorization of requirements are there. There are first functional requirement and non-functional requirement are there. What does these mean? Requirement analysis is very critical process. Means your requirement analysis, that is second phase, is very critical. If you have collected and gathered a proper requirement, then your design, then your coding, then your testing is proper. Okay, that is why it is called requirement analysis is your critical process that enables the success of system or a software project to assessed. Okay, that enables the success of the system or a software you are developing, or as a team member we are developing. This enables your success. Requirements are generally split into two types. Okay, first one is functional requirements, and second one is your non-functional requirements. There is a difference between functional and non-functional. What are the differences? In your function requirements, First point is a function requirement defines the system or its component. Okay. If you are developing your proper concept or a proper analysis is there, then there should be a function requirements also. And what does this mean? The function requirement defines a system or its component. Okay, it will completely define your system, each and every functions, what you will develop, what you will design, and after that you will develop that design. Okay, the complete functionality should be mentioned in your SRS, in your documentation. Okay, each and every functionality of your system and its component also. Okay, their subparts also, how they will perform, what functions you should use in your coding part. Okay, that should be explained in your SRS. It specifies what should be the software system do. Okay, how your system will work. Okay, what function you have used, that should be mentioned in your SRS. Function requirement is specified by the user. Okay, your function requirement is specified by the user, but as a team member or as a project manager, we have to note down each and every requirement from the user or the customer, and that is specified by a user. And as a developer, we have to know that. Okay. Function requirement is mandatory while developing your product, because we have to make the product according to the customer need. Okay. Then next is define a component level. If we are making a proper functionality, we are defining a proper components, their functionality means we are making a proper components levels also. Okay. Then next point, help you verify the functionality of the software. Okay. If there is proper documentation, proper components are made, how they will work, that will be written in a SRS, that will help you, please, as a member or as a manager, that will help us. Okay, because if we are creating another project, we will take the help from our previous SRS, previous project, that should be written in our SRS. We will take that help from a previous knowledge. Okay. Next point in your function requirement is functional testing, like system integration, end-to-end API testing, extra are done. Okay, in your functional testing, in our coding, we are make different functions. Okay, and these functions are related to each other. Okay, they are calling from a first function to second function, then second to third function is there. Okay, that calling, that should be, their interface should be tested. Okay, that done by your system testing, integration testing, and your unit testing also done in your functional testing concept, function requirement concept. Last point is your functional requirement is it is easy to define. Okay, when you have defined proper functionality, you have written all the functionality in your documentation, it is easy to use, easy to define, and customer also use that knowledge and work on your software. Okay, the example is there. While you are purchasing any type of appliance or any type of product, they will give you a manual. Okay, that product manual is there. The proper points should be written, how you will use that product. Okay, how they will perform their functionality. The manual should be there with each and every product. Okay, if you purchase mobile, in that box, mobile box, there is a manual. That is a documentation. Okay, that is a SRS. The same way, while you are making your software, second phase will tell that you have to create your product according to customer, and you have to write the SRS. That is the SRS is actually the manual is, from which the customer will read the points and use that. The same way, if we are making a software, we have to give a manual to them. Okay, that is a function requirement tells. There should be a function requirements there. Then what does non-functional requirements are there? This is also should be mentioned while drawing your SRS, while making your SRS. Okay, what is non-functional is? A non-functional requirement defines the quality attribute of the software. Okay, they will define only the quality attributes, main points. Okay, it places constraint on how should the software system fulfill the function requirement. Okay, they will make some constraints that how your function requirement will be fulfill your requirements. Okay, requirement of the user. Okay, that constraint will be written in your non-function requirements. Okay, how the function requirement will perform all these points. If there are constraints that if they will create a problem, that also should be mentioned in your non-function requirements. Okay. Non-function requirement is specified by the technical peoples. Okay, non-function requirement are specified only by a technical people. But a function requirement is specified by a users. Non-functional only specified by your technical persons who have a knowledge. Okay, architectures is there, technical leaders are there, and software developer are the technical person who have the knowledge of developing the software. He will specify your non-function requirements. If there are problems in some functionalities, they will write that if this type of error will raise, then go for these steps. Okay, there are options out there, and that options come under your non-functional. And it is not mandatory. These non-functional are not mandatory. Okay. Apply to a system as a whole. They will apply to complete system. These non-functional requirement. Okay. Help you to verify the performance of the software. Okay. This non-functional requirement are helpful for your verify the product. Okay. How your product is working. Then non-functional testing like performance testing, stress testing, usability testing, security testing come under your non-functionalities. Okay, your performance, how your product will perform, how the stress will be handled. If maximum users are working on your software, it is handled by your product or not. That stress should be checked. Okay, in your non-functional requirement, it is mentioned. Then there is a usability, how your users are using your product. Then security testing is also come under your non-functionality. Last point is here, it is usually more difficult to do. Okay, because it is only specified by a technical person. Those who have a knowledge. Only those person can define these non-functional requirements. Okay, that's all about your second phase. Then come to a third phase, that is your design phase. Okay. The internal logic of each of the modules specified in the system design is specified. We will create a design according to your SRS. Okay. Software design specify the software requirements. Okay. Means it is specified according to software requirement. That is software requirement specification. And define overall software architecture. After reading SRS, then designer will design your product or make an architecture of that product. Okay. Then further there is software design is further categorized into two parts. First is your initial design. Second is your detailed design. What does initial and detail means? Initial is it is an architecture design which defines and describes the main modules. Only main modules. Okay. Initial design is an architecture design which defines and describes the main modules or main components or your interfaces, main interfaces. Like main interfaces is your first phase is your while we are using a software, any type of software, we have to log in first. Okay, that is the first module. Then after logging, if we have given a proper login and password, then we will go for a next phase, next module. Okay, that is the first phase. That is your initial design will. Means these are the main modules. Login should be there. Okay, the proper design that is made, they should keep in mind there should be a login module is there. Okay, then for our next module, There should be a feedback module also. There is a payment module also. These are the main modules that's come under your initial design. Okay. By this, the software is split up into its components. Okay. An example is there. This involves the definition or selection of computer platforms and operating system or other peripheral hardware also. Okay. What does this means? That there is a division of components are there. Okay. And that components are completely depend on the platforms. Okay. Platform means your what type of your system or your software will be developed or used on which type of platform. It can be used on XP, it can be used on Windows, it can be used on your Linux or Mac. That is your platform and operating system. Okay, and also a operating system and also a hardware also. What type of hardware is there to use your product, and according to that we have to design that. Okay. Next point is the software component have to define to meet the end user requirement and to meet the need of possible scalability. Okay. Design should be according to customer need, and that should be written in your SRS. Okay. That should be written in your SRS, and design should also be made according to the scalability also. If your user will increase in a future, then your product should not go to a failure stage. If the stress on your product or on your software will be increases, okay, your product should be designed according to that. If there is 1,000 users, if after a month there is a lack of user on are using your product will not go to a failure stage. Make a product according to that, and if they are making, your architecture or your design should be according to that. Okay, then we will go for a code. If their design is good, then the coding should be. Next is the aim of this phase is to generate an architecture document. This serves as an input for the software design phase of the development. Okay, and the main aim is to make a proper architecture according to the documentation, that is SRS. Last is usually in this phase various documents are generated so that the software usually will receive a software architect document also. Okay, and while we are creating a design, we also make a design documentation is also there, and that we will study in our unit second. There is a triametrical, that is your diagram should be there, and that diagram is your DFD that I have told you. DFD is there, that is data flow diagram is there. Okay, these are the diagrams, and how your project will flow from one process to another process, that should be shown through a graphical representation, and that graphical representation is your diagrams. And in this software engineering, we will draw diagrams also. That is also your design phase. DFDs are there, UML diagrams are there. Okay, that is your design documentation. That is also we will perform in a practical also. Okay, using a different tool. We are using a open approach to plan our project, then to write a project. Write the documentation. We will use open approach, but when we draw a project, we will go for a DFD. Okay, and that DFDs are drawn by a tool that is Visio Draw. Okay, or Microsoft Visio or Smart Draw. Okay, these are the tool names. Okay, these documentation of design also be maintained. Then second categorize is your design phase is detailed design. Okay, in your initial design, we only design a main modules, main component, main interface. But in a detailed design, we will go for each and every phase, each modules. And detailed design is based on your software blocks defined by a software architecture design. The detailed design will break the initial designs. Okay, your complete division should be there. Detailed information should be there of each and every module. Okay, detailed design will break design further down into a code modules. Okay, further into a code module, some modules also. The interface and interaction of modules are described. Here, interfaces means if one module is completely dependent on second module, second is completely dependent on third module, their interface design should also be mentioned. That comes under your detailed design. And these design we will draw in our DFDs, data flow diagram. Okay, from one process to second process to third process, then further third process have their sub processes, and that is your complete design, detailed design. Okay, the activity and behavior of the software has to be defined in your details. Activity and behavior. Okay, how your single module will be working, their activity, okay, their behavior, that all should be defined in your detailed design. Next, the output of this phase is a detailed design document, which is the base of the following implementation. Okay. And in this also we have to create a proper documentation. Okay, detailed documentation should be there. And next phase is your coding phase. That is your fourth phase. And in coding phase, there is also a unit testing. What does coding phase means? Coding phase is to translate the design of the system into a code. Okay. Now your design phase, if it is done properly, then we will go for a coding phase. If design is okay, complete design is done, proper information is given, documentation should be there, then we will go for a code phase. Okay. Now the point is written that coding phase is to translate your design to your code. Okay. And your programming language. And coding will be done in your program. It can be in C, C++, Java, Python. Okay, these language can be used. Next point is there. The system is first developed in a smaller portion called unit. Okay. Single modules can be developed first, module by module. And these modules are made by a code. Okay. Then a single module code will be tested, and that testing is unit testing. Then second module will be test. Then third module. Individually testing is called of each and every module. Individual testing of each and every module is called unit testing. Okay. They are able to stand alone from a functional aspect and an integral later on the form of the complete software. Means first of all, we will perform a unit testing, then we will perform an integration testing, then we will go for a complete testing. Means system testing is there. Okay, that all come while we are performing a coding. Okay, after coding, we will go for an integration testing, then for a system testing. Each unit is developed independently and can be tested for its functionality. This is called unit testing. Individually testing is called your unit testing. It simply verify its unit meet their specification. Okay. While testing, we also check that it is according to the customer need. Okay. Individual testing is there. Each and every specification should be checked. And last point is this involves functional testing at the interface of the module. Okay. And in this, we also check the functionality testing is also there between a module. Okay, in a single module, there are different functions are used. They are called from a different function in a single module. That also should be checked in a single module. That is your unit testing. Okay. And next is your component integration, or you can say that integration testing. Okay, here is your diagram. I will explain according to a diagram. Unit testing means single module testing. Okay, individual test is your unit test. This is checked individually. This is checked individually. When both the modules are collected, then go for both the testing, both on these both modules, that is called your integration testing, integration or integrated testing. Or these are, in this we will check our interfaces. Okay, interface between unit 1 means one module and a second module. Okay, this is your integration testing. If there is a complete modules are there, then we will go for a testing that is called a system testing. Means all modules are collected, then perform on testing on that complete system. That is your system testing or complete testing is called. This module A, module B, module C are the individual modules. We will test individually. First module A will be checked, module B will be checked, then module C will be checked. If we are testing with the integration, with a combination, okay, then it is called integration test. If there are more modules, we will collect that all modules and perform the testing on them. That is called a system test. Okay, and further there are different level of test. There is a unit testing, that is your individual component will be tested. Then there is an integration testing, that is combination of two or more modules are there, then perform a testing on them. Their interfaces should be checked. Okay, then there is system testing, means your entire system will be tested. That is your system testing. And after that there is a step acceptance testing, and this testing is performed by your customers. Okay, that your customer will accept your product, that that is developed by us and used by a customer. If customer is satisfied, he will accept that product. If it is not, he will give his or her feedback. That comes under your acceptance testing. Okay, the test, the final system, and this is performed by your customers. And unit testing, integration testing are performed by your team members, developers. Okay. Then there is a integration that I have explained to you what is integration and system testing is. Okay. And that system and your integration testing come under your testing phase. And in your testing case, while you are performing a testing, you have to create a test cases. Okay, we have to perform a test cases. What does test cases are? Test cases are a small code, programming code that are placed in your software code and check your software whether it will work properly or not. Okay, this test case will be inserted or copy in your software or your product code. If it is work properly or it will show any type of error, that will be checked. Okay, if it is work properly or if it is a proper error, that he or she will manage that as a tester or a testing team will manage that error. That is that means your product is a good product. It is work properly. If it will show any fault message, any type of loop will be run. Okay, that means your product that is developed should create a problem while it is in market. Okay, for that we will perform each and every testing, and for that we will create a test kits or test suits. Okay, suits are there also, test cases also there, test suits also there. Okay, that all techniques we will study in our unit 3 topics. There is a testing techniques. Keep in mind there are a term used, that is test cases. Okay, then there are different approaches for your test cases, that is functional testing is there, then structural testing is there. We have to create a test case according to functional testing and according to a structural testing also. Okay, functional testing, what does functional testing means? Module to be tested and treated. Okay, each and every modules and their functions. In between your module there are different function. If there are 10 function, we have to check that function, we have to test that function. Okay, that function is called that technique is called, while we are testing the functions, that is called your black box testing. Okay, the technique name is your black box. Okay. The test case are based on the requirements, means your functional requirements, your functional modules. Okay, they will be checked, and that technique is called black box. Means these all testing are performed by experts, developers, testers. Okay, they will perform this testing. Okay, black box. Why it is called black box? Because those who haven't knowledge of coding, they will not know what testing is performed. That is why it is called black box. Means internal functionality will not be shown to a user, and how they are tested, it will not be mentioned or it is clear to the user. Those who have a knowledge can understand that. That is why it is called black box. What is going inside, it is not understood. Okay. And the testing is called a black box testing, and it is focused on external behavior of the system, only on external behavior. What it is working, that is only understood, but how it is working internal, how it is performing, it will not be understood by a common person. Okay. Next is operations and maintenance. This is your last phase, okay, of your SDLC also, and of your waterfall model also. The software is handed over to the customer before maintenance. Your after testing, you have to hand over the product to the customer, or customer or a stakeholders will use your product and give their feedback. Okay, according to their feedback, then we will go for a maintenance. Okay, the software is handed over to the customer and will be used first by the customer. Okay, then he or she will give his or her feedback. Then the customer will check it if his or her requirement are implemented, or now at this phase, customer will be checked that the requirement he have given to the manager, according to that requirement, the product is made or not. Okay, if it is not, then customer will be give his or her feedback that this product is not according to his or her requirement. Okay, that is the customer will check if his or her requirement will implement as expected, but he will also validate. Validate means he will check that is according to the customer requirement or not. Okay, the customer will be checked this product. That is called validation. In case there are change necessary, it has to fix to make the software usable or to make it fulfill to the customer wishes. Okay, if it is there is any change, then developer will accept that change and make the product, maintain the product according to the customer. Okay, then next point is waterfall model have the different phases, and all these your feasibility study, gathering, then your design, coding, testing, all these phases are used, but your maintenance phase take more effort. Okay, more effort of your software team. Okay, this maintenance phase, because at each and every step or according to customer need, the product should be maintained. All the problem which did not arise during the previous phase will be solved in your last phase. Okay, that is why it is called maintenance. All the problem that is arises in your previous phase, the waterfall model have the problem that there is no feedback concept is there. That is the problem, and all the problem that is arises, that should be checked in your maintenance phase. That is why it is called, it is a phase that will take more effort. And in your next slide, there is a diagram that is in your maintenance phase. Among all the life cycle phases, maintenance phase consume maximum effort. Okay, here is a bar graph that maintenance phase more effort according to your previous phase, because there is no option of feedback from your previous phase. Okay, then there is an advantage of your waterfall model. It is simple and easy to understand and easy to use, easy to manage. Okay, and there is inflexibility. Okay, this product is rigid. The rigid product is this, because We will not change this product in between your phases. Okay, we will not accept any requirement from the customer in between the phases. That is why it is called inflexibility. Okay, it is rigid product. Sorry. Each phase has specific deliverables and review process. Okay, there is a deliverable. Means if second phase will be complete, then go to your third phase. Third phase complete, then go for a fourth phase. Next is phases are processed and complete one at a time. Okay, that is one by one. Sequential manner is there. Work will work well for smaller project. Okay, it is waterfall model is usable for only small project, and that is well understood. Okay, if we have proper requirements, then we will go for this project and we will use which model? Waterfall model. If it is clearly defined, means proper definition, proper requirement is there, then we will go for a waterfall model. Well understood milestone are there, then go for a waterfall model. Easy to arrange risks are there. Okay, then go for waterfall model. Process and results are well understood. Document. Okay, proper document should be there. Documentation should be there. Proper. Okay, these are the advantage of your work. And disadvantage is no feedback module is there. If there is no feedback concept is there, high amount of risk is also there. Okay, not a good model for complex. Only for small project it is used. Poor model for long and ongoing project. For a complex project, it is not benefited. Okay, not suitable for a project where requirements are at moderate. Okay, if there is a moderate requirements are there, not proper requirements are there, then no, not go for this model, waterfall model. Okay, then we will use another model, that is our prototype model, that is second model. Okay, it is difficult to measure progress within the stage. Okay, that is no feedback. We will not measure the progress. What the coding module, coding phase is doing. Okay, what is design phasing is doing, that will not be checked in your waterfall model. Cannot accommodate changing requirement. Okay, cannot be accommodate the changing requirement. Means we will not change any type of product while we are going through our 5 phases. That is feasibility study, requirement gathering, design, coding, and testing. Okay, changing will be checked only when we are in a maintenance. Okay, that change from the customer. Okay, that will be accepted when we are in a maintenance. Okay, that's all about your waterfall model. Now we will go for a prototype model. Okay, this is your prototype model. Okay, what is difference in your prototype model and waterfall model? In prototype model, we will create a prototype, that is a dummy should be created. Okay, then that dummy should be hand over to the customer. Okay, he will check that dummy, accept that dummy, that according to his need, the project will be worked or a toy will be made according to the customer requirement. Then if it is accepted that model or that software, then we will create a proper model. Okay, first of all, we will create a dummy. Okay, dummy, you can say that to a prototype model. You can say a toy model. You also can say that a prototype model. Here is a diagram of your prototype. First of all, there is a requirement gathering. Okay, first phase is your requirement gathering is there. Then after gathering a requirement from the customer, there should be a quick design. Okay, sorry, decision. Quick decision from a manager, from a team members. Okay, quick decision should be made after collecting the requirement. Then build a prototype. Dummy should be made. Toy should be made. Okay, that is called a prototype. Prototype, build a prototype. Okay, then what the customer want, make a prototype according to that requirement and hand over to customer. Okay, hand over to customer. Customer will check that dummy, that according to his need, that is working or not. If it is according to customer need, customer will evaluate that dummy, and if he wants any change, if he or she customer want any change, then again to this process, that is refine requirement, incorporate customer suggestion. If while evaluation, customer is evaluating that dummy or a toy or a prototype, he will give his suggestion mode. If there is any change he wants, then again make a decision, then make again a prototype, again go for a evaluation. If it is successful, if it is accepted by a customer, then go for a next phase, that is acceptance by a customer. Means he is accepted that dummy, then developer, okay, then developer will go for a next phase, that is design. Okay, now your waterfall model concept again comes in your this prototype, then again design, then implementation, that is coding, then testing, then maintenance. Okay, this way your prototype model works. Okay, and this will cover your disadvantage or limitation of your waterfall model. If customer want any change, he will give his requirement in this prototype model only. Okay, then again developer will develop that model according to customer suggestion, then again develop, again it wants any change, then again refine the product. Decision should be made by the developer. Okay, then build a prototype, then again evaluate from the customer. If it is accepted by the customer, go for a design phase, then coding phase, then testing phase, then design phase. Okay, up to your requirement and till your customer evaluation, this is your prototype development, this is your prototype. Okay, up to this one, up to your customer evaluation. Okay, this is a prototype development, and after accepting that, your what process is started, that is iteration development. Means iterative waterfall model is there. Okay, prototype is a combination of prototype development plus iterative development also. Okay, that is your prototype is. The prototype model requires that before carrying out the development of actual software, a working prototype of the system should be developed. Okay, working prototype. Dummy structure should be made and hand over to the customer. He will check it. Okay, while you are purchasing, example is there, while you want to purchase any type of model, mobile phone, sorry, you go to a your showroom and you will check the dummy, how it is work. Okay, you will check each and every functionality from that. Then you will go to buy that product. Okay, the same way, if the customer want to develop any product, okay, he will give his suggestion to the developer, then developer will make a dummy and he will evaluate from the customer. If it is accepted by the customer, then go for a next. That all the prototype model works. Okay, a prototype is also called as toy model, also called as throwaway model. Okay, also called as a dummy model. A prototype usually turn out to be a very crude version of the actual system. That is a crude version. Okay, throwaway product this is. Okay, because we are creating a dummy. Then if it is accepted, then we will go for a proper product. Okay, so that is why it is called very crude version of the actual system. Possible exhibiting limited functional capabilities, low reliabilities, inefficient performance are compared to the actual software. In your dummy, we will go for a limited functionalities. Okay, inefficient performance is in your dummy. After it is accepted, then we will create a proper software according to iterative process. Okay, that is your complete structure of your prototype model. Okay, then advantage in your prototype model is it reduces the risk of incorrect user requirement. Okay, Because in a prototype, we will take a proper suggestion from the customer, okay, user, okay. Then after accepting the dummy from the customer, then we will go for our actual product. That is why reduce the risk of incorrect user requirement. Then good where requirements are changing. Okay, if the customer changing the requirement, go for a dummy only. If continuous change is there from the customer, make a product according to prototype model. Okay, regular visible process aids management is there. Okay, there is a proper visibility of processes there, because we are making a dummy showing to the customer. Then after accepting that dummy, we will go for the next steps. Support early product marketing. Okay, early product marketing means we are making a dummy and hand over to the customer. Customer will check it, give his or her feedback. That is a early product marketing. Okay, make a dummy, show to the customer. Okay, after acceptance, make another. That is early marketing is there. Dummy should be made, launched in the market. Customer accept it, make a proper. Okay, that is the early marketing. Reduce maintenance costs. Okay, in your waterfall model, your maintenance cost and effort is maximum. In your waterfall model, that is reduced. Okay, error can be detected much early as the system is made side by side. Okay, error should be detected, because in this we are also using prototype as well as iterative model. If there is any type of error in design, okay, iterative process will backtrack to the design. If we are in a coding design, if we are coding testing module face any problem, he will feedback to the designing phase. That is, a error can be detected much early. Okay, disadvantage of prototype model is that is this is unstable, badly implemented prototype often become the final product. Okay, this product is unstable because continuous change from the customer make the product unstable. Okay, difficult to know how long the project will last. Okay, how long it will work, that will be the difficulty in prototype model. How long the product will work, your software will be work, that will be create a problem in your prototype. Easy to fall back into the code and fix without proper requirement analysis, design, customer evaluation, and feedback. We will backtrack our product without any requirement analysis, without any design, without any evaluation. That is also a problem in prototype model. Okay, prototype tools are expensive. Okay, changing the product frequently, using prototype model, using extra resources according to customer need is make the product expensive. Okay, special tools, techniques are required to build a prototype. Okay, different resources are used, different tools are used, that will make your product cost effective. And if they are making a frequent change, time consuming should be there. Developer only go for a single project only if there is a continuous change from the user side. Okay, that's all for your today's lecture. In this lecture, we have studied only two models. That is your first of all waterfall model, that is categorized into two types, classical and iterative. And second model that we have studied that overcome the limitation of your waterfall model, that is your prototype. And it is also called your toy model, dummy model, as well as through away model. Okay, if you have any question, you can ask any type of question. Okay, I will unmute you, and the same time you have to also answer the poll.